So we've got a quadratic function is just a polynomial whose highest power is x squared. So I think you know that that is a quadratic, x squared. The graph is called a parabola, so I think you've heard of that vocabulary word. And we've done the parent function quite a bit already. So I'm just going to kind of zoom in here, and we're going to graph y equals x squared on this axis one more time. So the vertex is at 0, 0. And when you square either 1 or you square -1, you get 1. So you go up 1 on each side from the vertex. Then when you plug in 2 and you square 2, 2 squared is 4. So when you're 2 units away from the vertex, 1, 2, 3, 4, you're at a height of 4. And then you're at a height of 9, because 3 squared is 9. So those are the key points that I didn't really quiz you very much on that today, but on next Friday's quiz, it'll be all about graphing quadratics. So I like to write down the points 0, 0, 1, 1, 2, 4, and 3, 9. And you'll hear me say those points a lot because those are the parent moves for graphing a parabola. 1, 1, 2, 4, 3, 9. When we stretch or shrink it, we're going to change that 1, 4, and 9. We could make it twice as steep, so it'd be like 2, 8, and 18, or we could cut them in half, so it'd be like a half, 2, and 4.5. The other thing I wanted to write down one more time is, what is the domain and range for this graph? So domain, I can go forever to the left and the right, because this is like opening further and further, out. So the domain is all real numbers, but what's the range for this function? Y has to be what? Greater than or equal to 0. Yep, so all of my y-axis that I'm using is above the x-axis, right? So all these y values come out positive. So we need this to be able to do some of these other pieces. And actually, I'm going to skip standard form for a minute because that takes a little bit more learning. I want you to skip ahead to the next page so you can feel like, oh, I already know how to do this. We're going to skip ahead to vertex form because it links directly with the transformation rules. You might not know this formula, ax minus h squared plus k. You don't have to memorize that. I'm just going to tell you what a, h, and k do, so I needed to call them something. So this is called vertex form of a quadratic. We're actually going to talk about 3 different forms of a quadratic. I'm going to write it on here just so people watching from home. So there's standard form, there's vertex form. You don't have to write this down, but I'm showing you the 3 forms we're going to look at. And there's something called, intercept form. And they all have an x squared term. X squared is there, x squared is here, and x times x is x squared in factored form. So see how some of those letters are the same? So A always has the same job, no matter what format you're in. But B and C are only in standard form. H and K are only in vertex form. P and Q are only in intercept form. So they have different jobs, and they're going to help you graph the quadratic, giving you their different information. A is always your concavity. Concavity. So if A is positive, it's going to be concave up parabola. And if A is negative, it's going to be a concave down parabola. And that's the same in every single quadratic. You can always tell if it's going to be concave up or concave down. So you're going to see that 3 times when we go through every single, formula. H, this is your left and your right because it's inside with X. So H is right or left. So I'm going to say, like, how about X minus 5 would go to the right, but X plus 5 would go to the left. right? So we know that inside the parentheses with x, it's backwards what we think it is, just like on the quiz you took today. So what is K's job then? You can guess what K's job is. Right, that's your up or your down. So when K is positive, it's up, and when K is negative, it's down. Up, add something to it, down, subtract something from it. So these should be kind of a, a review, a practice, helping you practice the transformation rules. So let's do those two examples together, just so we can see this is the same that we've been doing all week already. And how would I describe this transformation? What does the x minus 1 do? Goes right 1, and what does this plus 3 do? Up 3. So right 1 and up 3. So I'm going to take my transformation rule. I'm going to graph my vertex, which is right 1 and up 3. There's my vertex. That's the bottom or the top of the parabola. And what is my a value for this problem if nothing is written there? 1. Yeah. So it is the parent graph. It hasn't been stretched. It hasn't been flipped. So if it's 1, there's kind of a 1. You could sneak a 1 in there if you wanted to. I'm just going to graph the parent moves that I talked about on the front page. So the parent move for a parabola is over 1, up 1 on both sides. So from the vertex, I'm just going to plot over 1, up 1. The next parent move is over 2 and up 4, right? Because 2 squared is 4. So from the vertex, I count over 2 and up 1, 2, 3, 4. And that's all that's going to fit, so I can graph it. Make sure that this right here from the vertex has a height of 4. Sometimes students start counting from like here. They go over 1 and up 4 units, so you need 2 high. You always want to start counting from your vertex. Over 1, up 1, over 2, and up 4. So that's it. You graph the transformation, and you use the parent moves. So 1, 1, 2, 4, and 3, 9. So let's do one more vertex form, and then I want to show you standard form. I think you'll remember standard form from Algebra 2, hopefully. All right, so what are my moves that I got, or what are my transformations this time? Describe what happened to this graph. So we're just practicing transformation rules. What would you say happened? Yep. Flipped over the, x-axis. The 2 is a stretch, so we're going to have to stretch that parent function. And then what does the plus 1 do? Left. So I always start by graphing my vertex. The vertex, if I'm only going to the left, is going to be just left 1 from the origin. So I'm going to plot my vertex. Now in my head, I'm thinking about what the concavity of this graph is. So in my head, I know, okay, I'm going down, right? So I'm not going to graph it up. I'm just going to graph it down as I go. Normally, I go 1, 1. What if I have to double that? Then I'm going to go 1, 2. So I'm going to go over 1 and down 2 units from the vertex. So I'm kind of doing my flip and my stretch in the same step. What would be the next point usually? 1, 1. Usually I go 2, 4. So 2, 4 is going to change to 2, 8, right? Twice as steep. So from the vertex, I'm going to go over 2 and down 8 to put my points right there. So it's twice as steep, and it's flipped over, and it's to the left. So see how that's exactly what we just learned about in transformation rules so far? So if you ever see vertex form, you leave it in vertex form and you do your transformation rules. So there's no real new learning for vertex form. The new learning is going to come for us for the standard form, because it won't always be given to you that way, right? They could give it to you in one of these 3 formats, and it's very hard to change between the formats. So you want to know how to graph it in the format they give you. So let's go back to the front page. I want to talk about standard form. So today I'm kind of planting the seeds of these different forms of a quadratic so that on Monday we can spend some time practicing them so you get really good at graphing quadratics. So standard form is ax squared plus bx plus c. So I call it the ABCs, and I usually go in order, A, then B, then C. And it's in order from the x squared term, then the x, and then the constant. So do you see how this is written very differently from what we just looked at? There's no parenthesis, there's an x squared, but there's also this x. I don't know if I'm going up, down, left, right. I do know something. So immediately my A value gives me two pieces of information, right? A is 2. What two pieces of information does that give me? I know my graph is going to do this and do this. Yep. So A equals 2. So I'm going to be concave up, right, which looks like this. And what else do I know about my graph? If it's a 2 that's sitting there. Is it the parent function? It's going to be stretched times 2. So I'm kind of storing that information. I know that that's what it's going to look like. Now I need to figure out where the vertex got moved to, and that's your B information. So negative B over 2A. Does that sound familiar? That should have been drilled into your head in Algebra 2, but you probably forgot it. But negative B over 2A is kind of like a formula you need to have memorized because it's how to graph a quadratic. It's also part of the quadratic formula. All right, this is going to give me my vertex. It's going to give you your x value of your vertex. All right, so from this equation, what is the B value? So this is A, this is B, and this is C. So I'm looking up here, A, B, and C. B is negative 8. They want me to do negative B. So what's negative 8, right, is positive 8 over, now I have to take 2 and multiply by A. A already is 2. So what's 2 times 2? 4. So the x value of my vertex is equal to 2. So I calculated it out by taking negative b dividing by 2a, and I got 2. Okay, so my vertex is at 2 comma something. How do I find a y value? So I need to plug in 2 for x. Right? Because if you have an x value, you could solve for the y value. So you're going to concavity, then you're going to do your b, so negative b over 2a gives you your vertex. We're going to plug 2 into this original function up here. So let's see, I'm going to have 2 times 2 squared minus 8 times 2 plus 6. So I'm just writing that down so that you have like, one example where you wrote that part down. And then you could use a calculator, or you could maybe do this in your head, hopefully. Order of operations, 2 squared is 4, and 2 times 4 is 8, so this is 8 here. You don't do 2 times 2 first and then square it, right? Because that would give you 16. Order of operations, you do your exponent, so I get 8 here, minus 16 plus 6. So what do I get? This is negative 8 plus 6. Negative 2? Yeah. So, ta-da, my vertex is at 2 comma negative 2, and I know that I'm concave up and I'm stretched by a factor of 2. So there's a lot of math in figuring out standard form. So that's going to test some of your, I think, putting something into a function and multiplying. All right, so I'm going to graph 2 comma negative 2, and I already said it was concave up and it's stretched. I just did a stretch on the last problem, right? It was 1, 1, 2, 4, 3, 9. So instead of 1, 1, I went over 1 and up, or I went down last time, but 2. And then 2 squared is usually 4, but instead of going up 4, I'm going to go up 8 this time, doubling it. So I'm doubling the y value. over 2 and up 1, 2, 3, 4, 5, 6, 7, 8. And I want to show you a way that you can check if you have the right answer. So I told you I call this the ABCs. We never did anything with C yet, right? So C is the way you can kind of check your work. C is your y-intercept. What's the C value in this problem? 6. What's the y value that I just graphed? It should be 6. If not, you did something wrong. So the y-intercept for us is at 0, 6. The reason is, if I'm on the y-axis, what does x have to be? X is always 0. What happens when you plug in 0 for x? You get 6, right? So these are called like the A, B, C's. So the A is your concavity. The B, you're going to have to memorize this formula right here, negative B over 2A. And then the C value, if you forget it, it's not the end of the world, but it's a y-intercept. It's a way to check your answer. Does that feel familiar even though you forgot how to do it? You should have been taught this at least once before, if not twice, but now you're kind of responsible for it. You've got to, practice this a bunch of times, and on Monday night's homework, I have you practice this a few times. So can you skip ahead? This is intercept form, so I'm skipping intercept form for a minute. Let's do a standard form example here. So skip ahead to number 1 on that next page. Maybe I'll do 1 and 2, and you can try 3 and 4, and we'll kind of end there for today. We'll save intercept form for Monday. At least you've seen vertex form. Standard form is new, and then we'll save intercept form. One thing I always do when I'm starting a problem like this, I like to identify my A, my B, and my C value before I start the equation, because sometimes someone might write it out of order. So if you get a problem that looks like this, y equals 6x minus 7 plus x squared, you can't read your A, B, and C value until it's back in standard form, right? This is A, this is B, this is C. You can't read this and say that that's A. So it's kind of nice if you identify what is A in this problem. If there's nothing written there, A has to be 1x squared. B is negative 6, and C is 4 in this problem. So my first step is I always think about the concavity and the stretch. What type of graph is this going to be? Concave up or concave down? So I just like to write next to the graph, okay, I know that this is going to be a concave up parabola, just so I check my work as I go. Like, okay, it's concave up. Is my graph concave up? Now I'm going to do that calculation. Negative b divided by 2a. All right, so I'm going to actually calculate this. Well, b is currently negative 6. So that makes this part of the equation positive 6, right? Because negative 6. So I got positive 6. And then in the bottom, I'm going to take 2 and multiply by 1. 2 times 1 is 2. And 6 divided by 2 is 3. So my x coordinate is 3 for this vertex. How do I find the y value? Yep, take this 3. So see if you can do that algebra. Take the 3, plug it back in on the right-hand side. So do 3 squared minus 6 times 3 plus 4, and tell me what you get for the y value, because that will be your vertex. So I'm going to do 9. Negative 6 times 3 is negative 18 plus 4. This is negative 9 plus 4. So negative 5 altogether. Is that what it comes out to? Might have to work on our mental math skills a little bit. All right, I'm going to graph 3 comma negative 5. 1, 2, 3, 4, 5. There's my vertex, and I'm thinking in my head, this is concave up, and this is the parent function, right? Because a was 1. So I can just do the regular moves for the quadratic 1, 1, 2, 4, 3, 9 and graph it. So you're going to get really good at the quadratic graph. So 1, 1, 2, comma, 1, 2, 3, 4, and over 1, 2, 3, up 9, 5, 6, 7, 8, 9. If I wanted to fit one more point, what point would I fit? 4, comma, yeah, over 4 and up 16. I wanted to do that last point so you could double check your y-intercept. What should your y-intercept be? 4. Is my y-intercept 4? Yes. And a lot of times students will make a mistake with either their vertex or their concavity and they won't hit the correct y-intercept. So you really want to check it at the end like that. All right, see if you can figure out your vertex for problem number 2. See if you can calculate negative b divided by 2a. Maybe wait a second before you graph it, unless you're really confident on how to do the 3x squared graph. But see if you can figure out your vertex. Plug in your a and your b value, get x, plug back x into the original function, solve for y. It's the mental math and evaluating the function that's the hard part for us. We got to get that, oiled up in our brain. So see if, oops, I think I forgot to put this one on the video. There we go. We found the vertex and tripled our values, so over 1 up 3, over 2 up 12. And we're doing the last example of number 3. Order of operations, you get positive 3. So now that you know where the vertex is, even if you didn't have time to compute the 3 on your own, take the vertex 1, 3 and see if you can do a downward parabola with a stretch of 2 to kind of wrap things up. See, I'll put the answer up so when you're done you can check it, but over 1, down 2, over 2, down 8. There's my y-intercept of 1. So those of you that got the vertex wrong, you probably will get the wrong y-intercept, and then you'll go back and check your math. Because I know plugging it into the function and squaring numbers and stuff, it takes practice. You guys have to get back that mental math, I don't know, skill, right? It's a skill. It takes some practice.